Okay, great. Thank you. So we'll get started. Okay, again, we'll come back, and then this Industrial Internet of Things workshop is sponsored by the UNI Metal Casting and the Foundry 4.0 centers. So during the presentation, please mute your audio and ask questions in the chat window. And then you may turn on your microphone at the end of the presentation for questions. And the video will again be recorded and then sent to you once it is ready. Okay, so this seventh week. Okay, again, my name is Jin Zhu, and then here's the link, which you could always getting the PowerPoint slides at that Google Drive. Okay, so today is the seventh week. Okay, we only have one more week left. I mean, after this one. So this week we'll talk about to utilize Google Firebase. Okay, so here's the outline and what we're trying to implement today. Okay, so basically we're going to try to configure a Firebase real-time database. So we'll go through the process, how we're going to configure that Google Firebase real-time database. And then we will look at set up the two clients as we're showing over here in this example. One is that node MCU, which is connected to a BME 280 through the I2C. Another one is the Raspberry Pi through that, again, the same thing through the I2C connect to a BME 280. So what they do is it's very similar to the last week. Last week we used the MQTT, and then the data is we established a blocker on a Raspberry Pi, okay, use the Mosquito. So that's a local blocker, okay, you establish a blocker. Now, then the cases we directly push the data to a cloud, okay, to the cloud, and then there's different cloud available, the service available. Here we're just using that Google Firebase real-time database. Okay, so this is overall, and all the data that going to store in the real-time database using the JSON format, which we're going to discuss later on. Okay, so the hardware, it's pretty much the same as the last week. And the software, so there's two parts of implementation for the software. One is for the Raspberry Pi. On the Raspberry Pi implementation, we don't use the Mosquito anymore, but we're going to use the Firebase admin that additional Python package need to be installed. Okay, so this is one thing. And while for the Node MCU, we're still using Arduino IDE. But in this case, we need to install a Firebase Arduino client library. Okay, we'll look at that to also go through the process. All the example project example code is available also in the GitHub. And then you can click the link, and then it should bring you there. And then since this is already 7th week, and then we already learned the process on the week 5 and the week 6, so it should be easier for you. The only difference is the Google Firebase setup, right? That portion is quite big, although it's still straightforward. So let's have a look at what is Google Firebase. Google Firebase belongs to our BAAS, or we'll see the back end as a service. That means the system does not really only provide like operating system or middleware and runtime tools, but also have some additional features to simplify the development of the system. For example, that user management and authentications. I mean, if you want to handle that all by yourself, that's pretty complicated task. And if using this like Firebase, it can handle that all for you, and also can hosting it, and then some additional features. For example, if you have developer apps and you can push and payments, all those things. I mean, for our application, we're not going to involve with that, but there's a features available. Okay, so it is we could look at go to their web page and quickly and have a look at that Firebase. So you would just see the firebase.google.com, and then you can go over there and then can have a look. So one of the things is with the cloud, different from if you store the data local, is that you're going to need what? There's a cost, right? So one good thing of these, I think most of those big vendors, companies provide some free or entry levels service available. So for example, this one, they have the Spark plan, which is no cost. So you can try it out, just apply for a Google account and then you can use it. And then they provide, I think that's mostly, my computer is really lagging. I hope you guys can still see it. So for example, they can have the authentication and then the store the data. So we'll see the stored data for that database is 1 GB. So that's really like a limited, right? It's a limited, but it depends on your needs. You could also upgrade it to the different service. And then for your testers, you know, if it's just a small project, you want to do that, that's okay. They could has documents writes, which is 20K writes per day. So that's if you don't really have a lot of data to push, in most of the cases that probably is already enough. Okay, it's already enough. So it's like what you could push over 13, 14. So it's like less than 5 seconds per write. Pretty much that's the range. Okay, so that's about the Google Firebase, and then computer is pretty slow. Okay, so for that Google Firebase, they actually have two different database available. One is the real-time database, another one is the Firestore. The difference, difference between those two, the major difference is there's the real-time database is not only SQL database, okay, or no SQL database. While for the Firestore is SQL based database. So SQL, we know it is stands for the structured query language. So most of the relational database are SQL based. Like for example, you know, the Oracle database, right? Those are traditionally all those structured query language based database. Okay, so the NOOC, no, not only, it stands for the not only SQL, that kind of database is what we used for the real-time database. So while those relational database like SQL-based database are well suited to handle some structured data, then they usually may have the problem dealing with that quasi-structured or unstructured data. So like for the sensors, I have this sensor, maybe have those different data fields needed to be uploaded to your database. While the other one, okay, I got a new sensor, they have detected different fields. So this one is for the temperature, while this one is has some additional fields that data I need to collect. So in that cases, we'll see if we're using the not only SQL-based database, it's much easier, and they can handle those unstructured data in a really scalable fashion. And then it has a better over scalability when your data volume grows, and then they simply can easily accommodate the new data structures and then or new data sources. So and then it's a good fit usually for the IoT purpose, and that's why we're just using the real-time database. Okay, in this case. So let's look at then how we're going to set up. So first, we're going to set up this Firebase, the project, okay, set up a project. And this project will be used both by your Raspberry Pi, okay, excuse me, both by your Raspberry Pi and also by the Node MCU, okay. So the first step is you will just go log into over here and then log into a Google account. If it's a company or school, it may not allow you to, if it's a company account or university account, you have to apply that. I think they may not allow that function getting disabled. Oh, that's possible. So you may need to talk to the IT. If you use your personal account, it's pretty okay. You could just set up a Firebase. All right. Okay. So once you go to there, then you will just say, okay, click the project, and then you will just put whatever name you want for your project. Okay, and you use the default setting is fine. So this is I use the IoT week 7 demo as an example showing over here. And then once you finished, then you will see a window that it's ready. Okay, so this is the first setups, and it will tell you where the database it is. So like over here, it's you know, the data, the user data is okay. When you set up that Firebase, it is located like US. They will tell you where it is. I guess in other country or other region, then they may store in a different place. Okay, so once you loading there, getting there, then you see over here, that's the builds. Once you click on the builds, once you log into there, and then they have different options. Here we'll just see, you'll see over here, they have a Firestore database and a real-time database, okay? We just talk about the difference between those two, and we'll choose to use the real-time database. So you will just see, okay, click the real-time database, and then you'll see, okay, created database. So once you click it, the created database, then they will asking you to setting a several rules. Okay, you can choose, and then they will asking you. There's two things: either study in the logged mode or study in the test mode. So some of them at the beginning you can try to study in the test mode, but in this example I'm showing just study in the locked mode. The difference is that if you're using the test mode, is that the security rules is pretty much true, and then they allow anybody to write and read to a database. However, they only allow it within 30 days. Okay, so you test it up, and then after that, they will force you to set up the security rules. Okay, security rules. So we will just study in the locked mode, and shortly I will go through the process how we're going to set up the authentications also. Okay, so once you're getting over there and then set up and then enable and they will click OK, and you should be able to already set up a real-time database. A couple of things, if it's an empty one, then you can see over here. Okay, let me see if I can show you this. Okay, so, and in this example, you can see, okay, so this is my demo. I already have some data, but you can still add some of the data there. So you can see this is database, that's the data, and that's they are updating the data. So when they push the data into there, okay, we will look at it more, but you want to try it out. If it worked, you could just, I could just add some data over there. I could also see, for example, I'm going to add some values. Okay, let's see, just see a number, and then you could see a value, let's see, 12.3 in this case. They will just add an engine, okay, into there. So they're using that specs format, and then the overall, how the data stored is follows so-called the JSON format. Okay, so this is some of the examples. And then one of the things you need to remember over here is this, okay, all that, this one, the URL is your real-time database's URL. And then you need this one for your later programming. Okay, so we're going to also, you want to write this one down for you to use. As I mentioned, all the data are stored in the JSON format. And then, so we'll go through what is the JSON format briefly, okay? So JSON stands for the JavaScript object notation. So initially it is a format, follows the JavaScript's syntax. But it's not just only used for the JavaScript, okay? Because it's a format, it's really lightweight and easy to use. It's very popular and commonly used for the API and then storing and exchanging data among different platforms. And then they also use for configures, like if I want to configure certain format. So for example, our previously that the rules for your database, right? Authentication and security rules for your database. That also follows the JSON format. Right, and it is language independent. It's just a text file, okay, just a text file. So you could open it, use in any platform using any text edit, okay. Many language, the programming language like a Python or Java, they has the JSON parser, and then they could just easily to dealing with the data with the JSON. So the JSON type, typically the type we can see over here in our example previously in the database we just saw, we used a number, right? They also have strings and then Boolean. Okay, so the number could use in any format, like for example, 10E5, that scientific notation also works. In addition to those format, we also has that num format, means if you have key, there's no data stored there. Okay, that's also the num type. And also the array, it is support array. And the most commonly used or important type is the objects. So for example, in this case, every inside of objects, we're going to use what? The use a pair of the brackets. The objects will be enclosed in a pair of the brackets. And then followed by what key, then the column, okay, and then the value. So the key has to be double quoted, okay, the key. So what kind of key, it depends on, what you want to use, and we will see an example briefly. If you have multiple items, then the items over here, and then you separate it using comma, okay? So we're going to look at one of the JSON example, okay? So over here, this is a data user to store the example, for example, a sensor reading, okay, or sensor, the data we're reading from the sensors. So we see over here, the yellow one, you can see on the top, and then to this bottom one, because this is a pretty large file, I didn't put all of them in there, but you can see over here, they has every pair of those brackets need to be matched, okay? So inside of this top level, you have the sensor 15, and also have see the test. So you can see over here within the sensor 15, I have a multiple of these object, right? Inside of that. So each object itself also will have what? To have a multiple of these entrance inside. So like objects inside of the object, they could be nested. Right, that makes it very easy to work with. So you have over here, in this case, I have a sensor 15, and this is that Unicode identifier. So that when I push the data into there, they know which one, this one is different from others, right? That's a Unicode identifier generated by the Firestore. Okay, so those are the data. Humidity, pressure, and temperature data. So over here for the sensor 5, we have 1, 2, 3 in this example. You have a 3 entrance. Well, inside of the test, I have node MCU A, maybe have another node MCU B. Within the node MCU A, you have will have a multiple entrance too. So this is the idea of how the JSON works. Okay, so remember that, and then we will use this one also for our authentication setup. Now we want to set up authentication. The good thing about the Firestore is that it provided the authentication and then user management. And then if you're just using Mosquito or others, these are pretty not so straightforward, and then could be time-consuming work to manage it. And then also the data transmission during the transition, okay, or transmit during the transmission, all the data are already being encrypted. We encrypted it, so that's also some advantages using those cloud service. Okay, so what we want to do is, again, we go to the builder and click on the authentication. Once it's launched, and you can see over here, so if you don't have anything set up, initially they will just asking you, okay, set up the sign-in method. Once you do that, you can just have to, because there's no method, so you want to probably just get into the sign-in method, you click on there, or set up the sign-in method, doesn't really matter. Either way works. And then you can choose easiest way. Okay, so they have additional providers. Some of them need to additional support or needs some additional upgrades of your service. But the native provider, those are easier. So the first one, we could just easily just choose the email and password. Okay, so we'll just need to enable this one, email password. And the good thing about this is the user could also, they handles the reset of the password, email address verification automatically. So you don't have to do anything, okay? Okay, so we can save it and then easily you could set up manually. Just over here, I add a user. Okay, so I can just add a user. So in this case, I'm going to add just my email over there. They will provide the user UID, and those are that Unicode. Also, every user unique ID is used to identify who is accessing your application or accessing your database. Okay, so once we add this one, so for example, like in this cases, I use that ID, and we can go back to set up database security rules. Okay, so once we set up this username, remember over here, when we set up that real-time database, okay, the rules, the set up these database security rules, we just in the locked mode. So in this locked mode, we see false. False means we don't allow anybody to read, don't allow anybody to write. Okay, false. So read operation is false, and write operation is also false. Okay, that's why we said it's a locked mode. Now, when we go back to over here, then we'll set up the security. We'll change the security rules. There's 4 different type of the rules that you could use. The first one is the read. Okay, so we're using dot read. So if it is allow a certain user to read that database, write when the data could allowed to write to your database, right? And the validate is see if that format value is valid. So for example, if I would like user pushing some data, and then I can limit the message length, okay? So let's see, I only allow them maximum 100 characters. If it's greater than that, does not allow them to write into my database, okay? So such things, although if the data range has to be, let's see, okay, between 0 to 100. If that you want to reinforce, you can use the dot validate. And the index on those are could be useful when you want to ordering all the querying the data. Okay, if I want to get in data for a specific duration. Okay, so you can turn on this index on. Okay, so there's a bunch of rules and examples. You could check the reference over there, but we'll look at 2 examples. So for example, in these cases, I will just say, okay, I'm going to have read authentication UID, meaning there's somebody is actually registered with the, the system. The UID itself is not empty. It's not none. And also the authentication token email, that email is my own email. This is for my case. And if you know, for this example, but you can certainly change that, right? So this is one example. And as I mentioned, the security rules, okay, security rules also follows the JSON format, So you could also doing the multiple levels. So this is for the root path, okay? So for the whole database, you have that. And then in this one, for the node 1, we actually index, okay, we specify the index that we can use for the queries. We enable the date and the time, okay? This is another example showing that. And in this case, you allow the user to read, but does not allow it to write. right? So it's very easy, and then you could determine what kind of rules you want to apply to your database. Okay, so next one, we'll first look at how we are going to work with your Node MCU. So the first one, what we want is that we need to obtain a project API for your programming. So that the key, it's like kind of a secret, or you see that used to identify if this app or your program is allowed to communicate to your database. Okay, so this is the web API key, which we're going to write down and then use for your program code. Okay, so this is first you're going to obtain this. Now download the code. Again, you are just getting the Firebase client.imo files from the GitHub. Make sure you connect it to the BME280 sensor to the Node MCU, of course, right? You want to connect it. And then once you download the code, you connect it, you need to configure this board and the port and port number to the Node MCU, and also the port number to be whatever connected to your board, right? That's similar to what we did for the last week. The same process, but over here we need to make sure you do install the Firebase Arduino library. So how to do this? Easy. You could just go to the library manager. So depends on which version Arduino IDE you're using. It could be slightly different. It could be under the tools. You click it, or for this newer version 2.3.2, you could just click over here. That's our library and the library manager. To click this one, they will open the window and just click on, you can just search the Firebase Arduino client and then install this library. There's or could be more than one of them, but the Mobisit, this one is pretty reliable. And I tested it does work. So I would recommend just using this one by the Mobisit. Okay. Okay, so once you install it, for me is you're going to see that is because I already installed it, so you don't see the install over here. Otherwise, you'll see install over there, and then you just click it, and then once you installed it, then go back to your program since you already opened, right? So a couple of things you need to set. Your Node MCU need to connect to a Wi-Fi. Okay, so you provide your network names and then the password and the API key, which we just mentioned earlier, and also the database URL. Okay, so whatever database URL we just established for your project. Okay, and then set up the username, email, password that you already registered into a project, so that allow the user be able to access the database. So here, the last two things is related to where you want to store the data. So in this sample, I just setting, okay, the RTDB path as the test slash and then node MCUA. So that means what it's under the root path of your root type database, and then under the test and the node MCU. Okay, so it's pretty easy to follow. And then that's why you observed before, like over here in this example showing, right over here, you see the test, and then you have the node MCU. If I click on the node MCU, then there's a bunch of different data into there. And then if there's the new data comes in, and then you will see it is actually pop out the color. So that's meaning they are updating. So at the end of this, over here, then the data is going to be, the new data going to be pushed. Okay, so this is about the node MCU. The last parameter is just the interval between two samples. So the unit is in the millisecond, and then that's why we put over here the 20,000. Okay, 20,000 means what? 20 seconds, pretty much. So you can easily change it. And then once you're done with that, the system should display the result of what's going on for an Arduino, and you can open that. So I can just show you. Currently, it's running. You can close this one. It's still going to run, but just to see, that's connected, and then the data. And that's push the JSON. Yeah, so that's the toggle. So I toggle that, and then you will see whenever there's more data updated, it's going to reflect in your serial monitor. And then you can just close this one. You don't really have to, it works. You don't have to have the interface open. This is just for the troubleshooting purpose. If you don't know if it works. Otherwise, you could just simply turn it off. Okay, you just close that ID. You don't need this one anymore. Once you uploaded the program or the code to the node MCU. Okay, so the node MCU needs to be powered, and then they will continue run the code. And then you can see there's several more data. That's the one we just, right? So over here, those are this is the new one, the green one. Oh, okay. It's in a different window, so you guys cannot see. So here's the database. That's the node MCU one. And then you see over here, it will update every, 20 seconds? So you see over here, the green one, which is the new entrant they just pushed in, okay? That's just a push in. So the three fields over here, if you look at in this one, okay, you have three fields. So if you look at these codes over here, I have a timestamp, right? Humidity, pressure, temperature, those are three values from that BME to AD sensor. Then the first field is the timestamp. Timestamp is that time when the Firebase received the data. Okay, received the data. Because for the node MCU, it does not really have a type base on it. So we use the timestamp and the Firebase, so included in there automatically. Okay, so updated. And we also noticed that for every engine, right, they have these like a bunch of characters, numbers, and alphabet letters together, combination of those. Those are the Unicode key. They could also use as a Unicode identifier because they are Unicode for this one across the whole database. Okay, and then so this is node MCU. Now let's look at the one very similar process. What happened? My screen, can you guys still see my screen? My screen is black now. Oh, okay, now it worked. Okay, so next portion, then we will discuss how we could use this similar implementation, but we using Raspberry Pi. So what we want to install is that Firebase admin package. So use the Firebase admin. The version I tested or used is the 5.4.0. There's the newer versions. You can also try to use it. And I just want to see that if you want to install the same version, you could use that. Otherwise, you don't have to specify, then they will just install the latest versions. Okay, and you can check what's the version on the status, use the pip show command. After that, again, you download the example code. So for the example code, I will just using the Firebase test. Okay. Inside of this one, we're going to, because we're using that admin account, that means you have a full access to that database. And in that case, you're going to need to generate a credential JSON file. So you go to the project overview and click on the settings. And then you click on the service account over here. And then there should have a key beneath it called the generated new private key. So you want to save this new private key. It is going to be a JSON file. So you want to securely store this file and you don't want to share it with anyone else. And if we assume the name is as this one, just for this purpose, you can save to the default name the system provided to you. So over here, we use this one as example. Okay, use this one just for the demo purpose. Now we store this one and download it in your computer. You need to upload this one into your Raspberry Pi. So how to do this? We could easily just using the SCP command. So you're going to just upload your local JSON file. You need to know where you store this file, okay? And then run the JSON file. And then this in your Windows, like a PowerShell, and then you run the command. And then the Pi is your account in your Raspberry Pi. If using different user account, username, then you change it. And IP address is your Raspberry Pi's IP address. So you have to change it accordingly. And then you can download in this means you will download the Pi's home path, home directory. And then if you want to download it to the different paths, then you can also write the full path in front of this file name, okay? So once you get this one, basically we'll show you similar to, so this is just showing the file which I already done, uploaded to my Raspberry Pi. So I have this JSON file. Okay, I have a JSON file and I have this test and I can run the code. Okay, I can run the code. So let's see, go back and just want to try if it works, like we use the test. Let's see, where's the database? Okay, so here's the database, which we have now. There's many engines and keep reading the data. My computer today is really lagging. There's some system. Okay, so that's a test. And then you have the node MCU for sensor 516. There's two different sensors. They are sending data to it. Now what we have over here, if I'm going to have a look quickly at your Firebase test.py, okay. So if you look at over here, there's several things, two things actually, that you need to change. So the first one over here, you see this, the credential file, the JSON file. you need to change depending on what file name you're using. And the second one is the database URL. Okay, so this database URL is this one, need to be this one. So it depends on what database you're setting. You want to copy this one over here. Then the second thing is that if you look at this example code, pretty straightforward to use. Okay, so what we did is we're going to get a reference, meaning we'll set into under the test, which use a set. We can change the name. Let's see, not using the set, for example. Let's see. Test. Yeah. We can just say, okay, demo, for example. Okay. And you will see, I'm going to set several data under those demos, which including my Boolean data, floating numbers, integer, and then some strings. Okay, and then over here, then later on, we'll see have created another reference to the database as the sensor 15. So the sensor 15 is not under the test, right? And we actually has pushing two data, which are different, numbers. We have just hardly coded over there and then see what is going on. Okay, so we're going to run this code and quickly and then see what is going to happen. You see, yes, you're going to observe what is going to happen in your database. Okay, over here. So if you observe the database over here, the number, the entrance is going to change. Okay, so the Python Firebase. It's just so slow. I have to type very slow, so you can't keep it. Okay, so we'll just run this code, and then you will observe. Okay, there's going to reading the data, and then you can see originally the first line, there's nothing, and stored over there under the test demo, right? So that's why you see the none, and then after I write those data into there, they will return this, okay? So if you look at over here, that's the demo, that's the thing we imported, and also the sensor 15 is where we push the to the data, okay? So you see over here, those are the two data we stored into. This is tested how does work. You want to make sure it actually connected to your the Firebase, it works and it works fine, and then you want to try to connect to that BME 280 and it works. Okay, so in this cases, we're just using two files. One is the Firebase BME 280, and another one is the save data. Save data, that's the same file that we used previously. In other words, we'll just not only push the data into the Firebase real-time database, okay? Not only to the cloud, but also we saved a copy in the local file, okay, in the Raspberry Pi, okay, in the Raspberry Pi. So that's just in case, and then that's the program, and you can run it over here again, similar to the previous one. You see over here, similar to the previous one. You need to update those JSON file and also the database URL. Okay, and then here the real-time database path, you can adjust it depending on what you want to adjust. And then the home path and node ID, those are used to determine where you want to store the data locally in the Raspberry Pi. Okay, so we could have a quickly look at if I run the Raspberry Pi, see what is going to, the code, or what is going to happen. So this one, I could, just for the demo purpose, my computer is so slow, just don't, lags a lot. Okay, so over here you have the test, and you have the demo, and this is 15. So how about if I just delete this one? So you can see it's easier. Okay. So we don't have that anymore. We have the node MCU, A, and the demo. We could also delete the demo if we don't need it. We could just see, okay, we delete it, and then and I'm gonna run my code over here. So I'm gonna run my Python Firebase and NVMe 280. Okay. So we just run over this one, which I do use setting the the sensor 515. What happened? Oh, that's probably my connection issue. See over here, I to see detect. Yeah, so I may not be able to show you. Sorry, unfortunately. Sometimes that happen. So I may need to have to shut down my this one and re-plug into it, and then it should be able to run. Yeah. So unfortunately, I probably have to shut down, and well, takes some time because the hardware connection may have some issue. I'm going to close this. What you're going to observe is that it should be able to see something like over here. Okay, should be something like this. So the node 1 or what is sensor 215 is depends on what your database name and then your real-time database path you're setting in your program. Okay, and each one has that data. So that's pretty much for the same thing for what you're going to observe, and for the same thing for the node MCU. Okay, the difference, the slight difference over here is that I in that from Raspberry Pi I also have the data and then time information, which is the time and data when you store that in when they got in the data from the Raspberry Pi. So it could be slightly different between you getting the data to you transmit the data to the real-time database. So but negligible usually, very small difference. Okay. So I think that's it. Let me see if my Raspberry Pi is be able to reconnect. And then if you guys have any question, feel free to ask. I think I'm done. There's some of the references over here, and then any questions? And then if I can have, I don't know if I be able to, my computer today is so slow. Okay, so we'll just run this, see if I be able to. Do not up yet. It's whatever. Okay, let's see. Now I should be ready. Okay, I just log it in. And then we have a look. Want to make sure it does actually have the I2C. See over here, this is connected fine. So I can go back to, I put the code onto my week 7 directory. So we need to see the Python. And then Firebase BME280.py. Okay, by the way, I want to also move showing over here. This one available, so you guys can observe at the same time. Okay, so here's another MCU A under the test, but this one we also have the one on the test. We have that BME 230. Okay, so let me check one thing. So code. What? Oh, I write the wrong number. Wrong should be BME 280, not BM. Okay, so what we have over here, I will just show you over here. So high interval is 30 seconds. Let's try to make it quicker. We'll change it to 5 seconds so you can see it's better. Okay. Control X, say yes. So you'll be able to observe it quicker. 280 line. Moment. See over here, that's the data. And then it should update it every time. And you can see over here. Yeah. And that's the data what we observed. Yeah, that's the data what we observed, and then that's 1, 2, 3, right? So it should be the same as this one. Yep. Okay, so that's pretty much, I think. That's it for today's presentation. Sorry for the delay. Any questions? Any questions? You're welcome. If not, and that's it for today. We'll see you guys next week. Bye-bye.